Let's look at a product of sums example where we have four variables, and this time we're given the shorthand notation, and this is the product of sums shorthand notation, right? Because we've got a big pi. And remember, this is just telling us where the zeros are at on the K-map or the truth table. And this problem, I really could ask for a product of sums expression and give you the sum of products shorthand, right? I could tell you where the ones are at, and in turn that would tell you also where the zeros are at. Doesn't really matter, right? It's still all the same game. So for this, right, you definitely want to go through and label our cells. So remember, this is a good thing to practice or get in the habit of doing is 0, 1, 2, 3, 4, 5, 6, 7. And don't forget, another important thing to remember is labeling the axes too, right? This is something that always gets screwed up. Remember, we're counting in grade code 0, 0, 0, 1, 1, 1, 1, 0. All right, and now I can place my zeros in the K-map. Remember, this is telling us where the zeros are at. So we've got 0, 1, 2, 4, 5, 6, 6, 8, 9, 10, 12, 14, 15. So that means that the rest of these guys are ones. I'm not going to draw the ones in here. We'll just know that we're dealing with the zeros for this case. So let's go through and find our implicants. And we'll circle with blue. Let's see here. Well, remember, with all our K-maps, we still have all of our edges touching. So this edge here is touching this edge. And so that means we got a nice, big, juicy group of 8 that we can circle here. So there's that group. And then just as I was doing that, as I cut over this, I said, oh, here's a nice other group here that I can get, right? Here's a nice group of 4. Actually, let's do different colors here so we can keep track of what implicant is what. So there's another prime implicant, right? That can't get any bigger. Let me see this 0 here. See that it could grow in size. Or maybe I'll do this burgundy color here. Right, it could grow in size that big, but it could also go over the side of this border and be another group of 4. So let's do that. So that covers that 0. And the last thing we've got is this guy right here. So to get that guy, let's just do this pink color here. And that's the biggest that implicant can get. All right, so it's quite a few implicants here. That's why I kind of tried to do different colors to break it up. But let's figure out what our terms are. So of course we're going to have x equals, and let's look at this first big implicant. So what's staying the same in this big implicant? Well, we know A and B are all changing, right? Because we can see we've got every possible combination there. It looks like C is a 0 here and a 1 here. And D stays as a 0. So it looks like D is our constant. So what I'm going to do here is I'm going to write D, and I'm not going to prime it, right? Since D is a 0, for product of sums, we do not prime zeros, right? All right. Now, let's do our green implicant there next. So our green implicant, what changed? Oops, Look, I already made a mistake. See, that's why going from product of sums and sum of products can be a little confusing because you might forget what your terms are. This is product of sums, and so that means that we need to be anding things together. So that means we put an and just to kind of keep our notation straight, I'm always going to put my individual terms in parentheses, even though I'm not doing any oring here. I'm going to put that in parentheses. Doesn't hurt. So now we're going to do our green term, and let's see what stays the same here. So it looks like a stays the same as a constant 0. So we're going to have a not primed. And it looks like c stays as a constant 0 as well. So we're going to OR that with c. And that's that term there. So we'll put that in parentheses. And now let's look at this kind of burgundy term here. What's staying the same there? Looks like a is a 0 here and a 1 there, so it changes. B stays as a constant 0. So B is staying as a constant 0, so let's throw B in there. Start a parenthesis. It looks like C stays as a constant 0 as well. So we're going to OR that with C. All right. And looks like last but not least is our pink term here. So let's see what stays constant. Looks like A stays as a constant 1, as does B. So that means since it's a 1, we have to prime it. So A prime ORed with B prime. It looks like C also stays as a constant 1. So we're going to OR that with C prime. And that's all of our implicants. So once again, it's a little bit less intuitive than the sum of products, but it's still usable. And in some cases, it can be a little bit more optimal, actually. So right, we can see our product of sums form here, right? We've got a sum here, a sum here, a sum here, and technically a sum there. And then we have a product where all of these guys are anded together, and we consider our anded together terms to be products.